Okay, so let's do the very first one on the homework. Let's look at number 13. Okay, I know it says to do this by graphing, but we're just going to do all of these using algebra. All right, so the very first step is we have to get this thing equal to 0. All right, so we're going to have x minus 5 over x, and in order to move this 2 over, we're going to subtract it. So negative 2 over 1 is greater than or equal to 0. Now the right side is equal to 0. That is step 1. We need a common denominator so that we can get these together, and our common denominator would be x. So I have x minus 5 over x minus 2 times x over x is greater than 0. Okay, let's go ahead and distribute our negative 2 and join our like terms. So x minus 5 minus 2x all over x has to be greater than 0. We have negative x minus 5 all over x is greater than 0. So step 1 is complete. We have a single fraction with some equality and 0 on the right. Okay, so step 2 is we're going to set the numerator equal to 0. So negative x minus 5 equals 0. I would add the x over, so I get negative 5 equals x. And then I'm going to set the denominator equal to 0. X equals 0. That one is already solved. Okay, so step 3 is make our number line. Negative 5 and 0. Okay, we have to try numbers on the left, the numbers themselves, number in the middle, again one of our critical points, and a number to the right. We're plugging these back into the original equation. X minus 5 all over x is greater than 2. So let's rewrite that so we do not forget. Okay, so let's pick a number to the left of negative 5. Let's pick negative 6. And let's plug that in. Negative 6 minus 5 all over negative 6 needs to be greater than 2. Negative 11 all over negative 6. Two negatives make a positive, greater than 2. This doesn't quite make it to greater than 2. So this is false. Okay, let's try plugging in negative 5. Okay, negative 5 minus 5 all over negative 5 has to be greater than 2. Negative and negative plus a negative makes that negative 10 all over negative 5 greater than 0. Two negatives make a positive. 2 is greater than 0. Therefore, closed circle. That is a true statement. So we can include it since it's a true statement. Now let's pick one in the middle. So something between negative 5 and 0. Let's pick 1. 1 is easy. Okay, so 1 minus 5 all over 1 greater than 2. Negative 4 all over 1 greater than 2. Is negative 4 greater than 2? No, it's not. So this is false. Okay, let's keep going. Maybe we've made a mistake here. All right, so let's keep going. Let's pick 0, and we notice if we pick 0, that would make our equation undefined. So we're going to make an open circle. Can't fill that one in. Okay, so, oh, I see what I did. Okay, so let's look at what happened here. Is 1 between negative 5 and 0? No, it's not. But this value we could use right here because 1 is actually on the right side of 0. So we already know that this one's going to be false. So let's go back and pick a number that's actually between negative 5 and 0. So let's pick negative 1. Okay, and let's plug it in. So negative 1 minus 5 all over negative 1 needs to be greater than 2. Okay, so negative 6 over negative 1 greater than 2. A negative makes a positive. 6 is in fact greater than 2. So originally we thought this was false because I reused the wrong number. It is now true. Okay, so we could fill in our graph right here. So let's talk about how to write that. So we have our x in the middle this time because it's an and. Okay, so we have an and. X in the middle, we have a -5 to the left and a 0 here. This one is an open circle, so I cannot have an equals to. This one is a closed circle, so I do have an equal to. And there would be your final solution.